Today we're going to work on simplifying radicals. One of the things that I saw in helping people with homework this week is that one of the things we're having trouble with is getting and knowing how square roots work. And so I want to take today to kind of strengthen that knowledge base, because we're going to use it next week as well. So it's going to be important for us to know how simplifying those square roots are going to work. So on our whiteboards here, I want you to work along with the problems that I give you so that you see how these work. So first one I want you to do is I would like you to simplify the square root of 24. Oh, good. A lot of people remember this process. I called this building the tower. We divide by the smallest number we can. So we start with 2, and we go until we can't divide by 2 anymore. So divide by 2 here, we get 12. Can we still divide by 2? Yeah, we can still divide by 2. We get 6. Can we still divide by 2? Yeah, we can still divide by 2. We get 3. Can we still divide by 2? No! We can't divide by 2. We got to divide by 3. So we circle our pairs. Here's the important part. Want to make sure that we get this part right. Any pairs go outside the square root. So I have a pair of 2s, so I'm going to have a 2 that's outside the square root. And then inside my square root, I've got a 2 and a 3. If I have things both outside the square root or both inside the square root, then I'm going to multiply them together. So this is going to be 2 times 3 is 6. All right, let me give you another one. Square root of 18. Pair of 3s go outside the square root. 2s by itself, it stays inside the square root. 3 squared is 2. Questions on that before I give you another one that's a little bit harder? Okay. Square root of 80. We had 18. Now there's ET. start by seeing if we can divide by 2. Can we divide by 2? Yeah, we can divide by 2. We get 40. Can we still divide by 2? Yeah, we can still divide by 2. We get 20. Can we still divide by 2? Yeah, we can still divide by 2. We get 10. Can we still divide by 2? Yeah, we can still divide by 2. We get 5. Can we still divide by 2? No! We can't divide by 2. We got to divide by 5. Here come our pairs. The 5, oh, it's all by itself. It's got to stay inside the square root. The 2's, I got a pair of 2's here. I've got another pair of 2's here. Since they're both outside the square root, we're going to multiply them together. 2 times 2 is 4. Square root of 5. All right. Next topic. So, new idea going on here. This one's coming up all the time on the homework. So I want to make sure that you know what it is. A couple of you have got it and know what it is. A couple of you have got it, but you're making it too complicated. Here's the long way. This is squaring is a shorthand way of writing multiplying something by itself. So this would be square root of 6 times square root of 6. And that multiplying is both inside the square root. So if they're both inside the square root, I can multiply them, and square root of 6 times square root of 6 is square root of 36. And guess what? The square root of 36 is 6. Now, I want to convince you and jump you straight to the fact that this answer, looking at this and saying that the answer is 6. And the reason that is because square root and the square are what we call inverse operations. In other words, they undo each other. So if I take a square root and square it, those undo each other, and I should wind up back where I started. It'd be like if I took 6 and subtracted 4 and then added 4 back. Well, if I have 6 things and then I take away 4 and then I add 4 more, I'm back at 6. If I take 6 and divide it by 3 and then multiply it by 3, well, I'm back at 6. So in the same way that addition and subtraction undo each other, multiplication and division undo each other, square roots and squaring undo each other. It's the same thing that we do when we solve an equation. If I have x plus 6 equals something, then I subtract it to get rid of the adding, and they'll undo each other. If I have 6x equals something, then I divide to get rid of the multiplying. And if I have x squared, then I solve that by taking the square root of both sides. Square root undoes the square. And so if I have the square root of 6 squared, that's just 6. All right, let's watch it happen again. So next problem, square root of 14 squared. And if you don't have the answer yet, then you're taking too long. The square root and the square undo each other, and the answer is 14. Let's watch it happen one more time. All right. This is going to be a really big number. I mean, there's no way you guys are going to get it so fast. Five seconds. Go, 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 go. Okay, time's up. What's the answer? Oh, wow, you guys are fast. It's 8,743 because the square root and the square undo each other, and so the answer is 8,743. Okay, the reason I say that is, let me take the example of one of the problems from the homework. And I'm wanting people to know this and catch it in their head because a lot of times people go to the calculator and then get the wrong answer. Let me show you what I mean. This was something that I saw pretty often when I was helping people with homework earlier this week. Was I wanted to do the square root of 122 squared. And so the way that I saw people do that was they did the square root of 122. And they got this decimal, and they're like, man, that's a long decimal. I'm not going to put all that in. I'm just going to, that's really close to 11, so I'll just keep it at 11. And I'll just square that. And because of that rounding, they concluded that the square root of 122 squared was suddenly 121. It's not. It's 122. We know that. And so that makes a difference when we're talking about something like with our Pythagorean theorem thing, whether c squared matches exactly with a squared plus b squared. Because using 122 versus 121 makes a difference as to whether the things match or not. And so then that leads you to the wrong answer. So if you insist on the calculator, you'll hear me say this a lot over the next couple weeks. Do not round until the end of the problem. In other words, on this problem, if I absolutely had to, and I have the square root of 122 and I have that decimal, I'm going to take that exact value, that exact decimal, and square it. And now I get 122 like I'm supposed to. If you need help with how to do that on your calculator, then let me know. But what I would prefer is that you look at square root of 122 squared on your paper and be like, oh, that's 122, and not even need the calculator. That's where I'm trying to get you to here. All right. New topic. Yeah, make sure you're doing these along with me. At no point today am I going to want decimals. We are working with seeing how square roots are going to interact with each other. So square root of 2 times square root of 5. They're both in the square root, so I can multiply them, and it's square root of 10. Okay, good on that? All right. Let's take a different one. Square root of 4 times square root of 3. Now, this time, if the square root can be simplified, it will be able to be simplified. I want you to simplify it. So that might require you finding your pairs and taking them out of square root. And look at that. We got a pair of 2's can come out of the square root. We have a 3 by itself. It stays in the square root. 2 square root of 3 should be our final answer. Now, I've done this between yesterday and today, and I've only had one person catch it this way. That's the long way to do it. The short way to do it is to say, wait a second. The square root of 4 is 2. Done. If you catch some perfect squares, then please use them. All right, moving on. Once again, I'm going to ask if the square root can be simplified, then simplify it. So first off, sorry, there's no perfect squares to be found here. So this should be square root of 60, right? 6 times 10. So multiply inside square root. And then see if square root of 60 can be simplified. You should have a pair of 2's coming out of the square root. You should have a 3 and a 5 by themselves. No pair to go with them. Left inside square root. So 2 squared of 15. All right. Next. Well, a few of you got it right away. Nice job. And what I mean by that is that a few of you caught right away. This is another way of writing the square root of 5 squared. That's what squaring is. Squaring is shorthand for multiplying the same thing together a bunch of times. Or in other words, squaring would be multiplying something by itself. So square root of 5 times square root of 5 is the square root of 5 squared, which is 5. So the answer there is just 5. Which is the square root of 25. 25 is perfect square, if you wanted to do it the long way. But hopefully we're going to get to the point of recognizing, oh, square root of 5 times square root of 5, that's 5. In the same way we recognize that this is 5. All right, let's try another one. How do I want to do this? Let's do this. No, because that... Let's do it this way. Here we go. That's what I want. So hopefully we're at a point where we multiply what was inside the square root, and we got the square root of 200. And so now you're going to be looking to see if the square root of 200 can be simplified. Questions? Next one. Two seconds. Go, 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 go. Okay, time's up. What's the answer? It's 21. Square root of 21 times square root of 21 is 21. I'll give you a tough one. We build on the idea of squaring something in a square root. This was on one or two problems on the homework as well. This was a little bit trickier. I'll give you a hint. The answer does not involve 15. If you have something like this, then we're going to square each piece individually. So when we square this, it's going to be, I have 3 squared, and when I square 3, I should get 9. And then I have the square root of 5 squared. And when I take the square root of 5 squared, that's going to be 5. Right? Square root of 5 squared is 5. We've been drilling that into your head. So 9 times 5, 45. Okay, let's do another one of those. Two squared is 4. Square root of 7 squared is 7. All right, 2 more things I have to show you. Okay, first of all, one place the calculator is not useful for getting the decimals out of the square root. Here's one place where the calculator is going to be useful for us, is if we want to check our answers and that we're simplifying this the right way. So 5 squared root of 2 times square root of 10. Then we can use the calculator here to check that square root of 2 times square root of 10 is simplifying the way that it's supposed to, that you're doing the problem correctly. So if I have square root of 2, let's see, square root of 2, I'm going to arrow over to the right, say I'm done with the square root, times the square root of 10. All right, it's about to give me a big decimal. And square root of 16 is 4, square root of 25 is 5. So square root of 20 is going to be somewhere in between there. 4.4721, I don't care. It's a big decimal. Keeps going. All right, what I do care about is that whatever I say that this simplifies to should equal that long decimal. So if you're not sure if you're simplifying it correctly, then what I could do is say, okay, I think that square root of 2 times square root of 10 should be square root of 20. So let's put in square root of 20 and see what we get. And we're hoping that it matches what decimal we just got out. Does it? Oh, yes, it does. And we can do this again when I go to simplify square root of 20, because circular pairs go out. They should give me a pair of 2s that go out, and a 5 by itself stays in. So it should be 2 square root of 5. So I can put 2 square root of 5. Come on, 4.47, whatever it is. Why do you hit her? Oh, there it is. Yes. We did it. So you can use that kind of process to double check that the things you're simplifying do actually work out the way that they should. Okay, one more idea to throw at you. This is a new one. This is something that we haven't done. But I want to introduce you to the idea because it's something we're going to do more next week. idea is that I don't want a square root on the bottom of a fraction. I don't want to be thinking about dividing by the square root of something. So I'm going to simplify by getting the square root out of the bottom. And the way that that's going to happen is this. What I want to convince you of here is, number one, this works. It is a legal math move to do. And number two, that why this works. That I'm not just pulling this out of nowhere and that you would be able to come up with it. First of all, why can I do this? Because the square root of 2 over square root of 2 is 1. Anything divided by itself is 1. 5 divided by 5 is 1. 8 billion divided by 8 billion is 1. And square root of 2 divided by square root of 2 is 1. And so, I have this 1 that I'm multiplying by. And anything times 1 is itself. So if I'm multiplying by 1, I'm not changing whatever decimal that is. So that is legal to do. Why is it useful? The reason it's useful is, remember, my goal is that I don't want a square root on the bottom anymore. Well, on top, the not useful part, I have 3 times square root of 2. That's going to be 3 root 2. On the bottom, here's the key part. I have square root of 2 times square root of 2. And here's why I chose it, because I know that square root of 2 times square root of 2 is 2. And guess what? No more square root on the bottom. And then on top, I have 3 root 2. We're going to use this a lot more next week. But the idea is that I'm matching whatever square root I have on the bottom. So if I had a square root of 5 that I wanted to get on the bottom, then I would multiply by square root of 5 over square root of 5. Because square root of 5 times square root of 5 is 5. And now no more square root on the bottom.